Hi, my name's Chris Clark. I'm with Liberty Resources and I'm our production engineering manager. What I'm going to be talking about right now is why do we choose hydraulic jet pumps for our artificial lift strategy in the Bakken and Three Forks play in North Dakota. What I'd first like to point out to you is this representative decline curve where you can see there's an oval around where we start to bend from high initial production rates down into a terminal decline rate. And the first thing that Liberty Resources asked ourselves when we went into this play was how do we best handle this part of the decline curve with one single artificial lift methodology, where we've got a high production rate to start off with and then a low production rate when we get to terminal declines. And we can see upwards of 8 times of fluid production from the terminal decline rate to the high rate when we first need that. And there are not very many artificial lift strategies that can handle those types of multiples. So in order to answer that question, we built ourselves a scorecard of relative advantages and relative disadvantages where we compared ESPs, gas lift, rod pump, and jet pump. And then we have a set of questions where in scoring these, 1 is poor and 5 is excellent. So the questions we looked at and scored for each one of these methodologies was depth to lift point, high production capability, low production capability, remote friendly, i.e. can we run this with some fuel gas if we don't have electricity available? Can it handle sand and proppant production as well as any other solids that can be produced out of wells? Can it handle high production ratios or swings in production ratios for water oil ratios and gas oil ratios? And then lastly, how effective can we chemically treat our wells with each one of these methodologies? When we went through and scored these for ourselves, jet pumps had the highest range of 24 to 29, and with ESPs ranking second from 19 to 26. And in this particular instance for ourselves, gas lift was not applicable because we were doing single well batteries at this time. However, this can be different for each operator. And one of the things I would encourage other operators out there is to build this scorecard relative to the basin that you're playing in and the types of wells you're drilling in. And as Liberty moves into other basins, we will develop a scorecard that is basin specific. The next way that we compared artificial lift methodologies was on a rate versus depth method, showing 2 different charts here, both of which have depth on the y-axis and barrels of fluid per day on the x-axis. What I'd like to really point out here is the green dashed line for the hydraulic jet pump. Jet pumps can lift wells down to 16 to 18,000 feet deep and have production rates up to 100,000 barrels of fluid per day. And it has the widest operating envelope out of any of the artificial lift methodologies that are compared here. The other one I'd like to point out is the beam pump, which is shown in the solid green. Beam pumps are limited to roughly 11,000 feet. And at that depth, they can only move 300 to 400 barrels of fluid per day. The reasons for that are limitations on the gearboxes for the pumping units, as well as limitations on sucker rods, which are going to be dictated by your tubulars. One of the main reasons why we chose hydraulic jet pumps using both of these types of comparisons is, again, we're trying to match the well's productivity with the pumping capacity of the artificial lift methodology we're looking at. When we're at those higher levels, where we're at those 8-time multiple levels, beam pumps are not going to be able to optimize our production. We're not going to get the cash flow we're looking for, whereas with a jet pump, we can optimize that jet and throat and nozzle combination to meet the well's productivity with the artificial lift capacity. So the last way that we compared artificial lift methodologies, and really this is a comparison between sucker rod pumps and jet pumps, was on a CapEx basis and a LOE basis. On the CapEx side of things, jet pumps are between $250,000 and $365,000 to install, and that range comes from whether or not you're a gas-fired engine or you're electrically driven, with the gas-fired being the more expensive. On the rod pump side of things, we're at $342,000. So they're relatively comparable on a CapEx basis. And then comparing it on an LOE basis, the jet pumps are between $8,000 and $18,000 a month to run, and the rod pumps are around $12,000 a month to run. Now the range on the jet pumps from $8,000 to $18,000 is coming from whether we're using fuel gas in the field where we can't sell our gas. That's the $8,000 case. And if we're hooked up to electricity, we can be upwards of $18,000 a month, depending upon how much hydraulic horsepower is necessary to lift the well at any given point in time. Comparing that to the $12,000 for the rod pump, that $12,000 does assume rig interventions. So again, pretty comparable on the two sides of things, and to point out again that the hydraulic jet pumps can lift significantly more fluid than a rod pump can at the depths that we're looking at in the Three Forks and the Bakken. So I'd like to summarize up this first segment on why Liberty chose jet pumps. When we looked at our scorecard, we were obviously had the highest numbers compared to the other lift methodologies that we had. And again, that was comparing multiple operating conditions. Secondly, the capacity of the jet pumps as an artificial lift methodology has the widest envelope of operating capacity and can match the well's productivity at any given time. Whereas sucker rod pumps and some of the other methods can't necessarily move the fluids that the wells are capable of doing when they initially need artificial lift. And then lastly, the costs on the CapEx side and the LOE side are comparable for both of these methods. That being said, we can increase our cash flow significantly using jet pumps over sucker rod pumps. In the next segment, I'll be talking about the results of our jet pumps for the Bakken and Three Forks in the Central Basin of North Dakota.